In this walkthrough, we model a full-scale coal power plant by interconnecting modular calculators. We start in the furnace, where coal combustion releases the thermal energy. This heat is captured by the steam generator, elevating feed water to a superheated state. From there, the steam expands through the turbine for expansion to produce mechanical work. The low-pressure exhaust then enters the condenser to simulate the phase change back to a liquid before the high-pressure pump resets the cycle. Because these systems are interdependent, engicloud employs a fixed-point solver to cycle through the subsystem. Let's look under the hood. Each block is a self-contained Python module, allowing us to integrate industry-leading libraries like Cantera. In the furnace, we define a proxy fuel mixture of volatiles to simulate gas phase reactions. This allows Cantera to solve for the exact chemical equilibrium of the flue gas, while we anchor the total heat release to the actual low heating value of the coal, ensuring both chemical accuracy and energy conservation. Next, the steam generator bridges the gap between combustion and water cycle. Here we integrate the IAPWS97 library for industrial-grade steam properties. The script executes a dual energy balance, tracking the enthalpy drop of the flue gas against the heat gained by the water. This ensures the digital prototype respects the first law of thermodynamics with engineering precision. The superheated steam then enters the turbine. Here we model a robust isentropic expansion that converts the thermal gradient into mechanical work. Following expansion, the condenser resets the fluid to saturated liquid state. Finally, the high-pressure pump calculates the work required to return the feed water to boiler pressure. This handshake between the pump and the boiler closes the loop, transforming the raw chemical reaction into a fully verified power cycle. Finally, the performance calculator synthesizes the data into actionable metrics. By subtracting parasitic pump loads from the turbine's output, we calculate the net power and overall cycle efficiency. With this, you've moved from raw equations to a functional, shareable engineering tool. This is the power of engicloud.ai, turning the world's wisdom into executable reality.